In order to rewrite an equation, we're going to solve an equation for a variable. To do that, we're going to treat all other variables as constants. If we look at example number 1, we have a linear equation, and in our linear equation we have an x value and a y value on the left and a constant on the right. The 4 is the coefficient for x and the 9 is the coefficient for y, and 30 is just a number, it's our constant. This linear equation is written in standard form. Standard form is really useful when we are talking about word problems. There's other uses for it, but in this class, the most use we will find out of standard form is word problems. Now, in order to solve for y, we need to isolate y. We need to get y by itself. So we need to get rid of this 9. To get rid of this 9, we're going to multiply by 1/9. But I don't want to do that yet. First, I want to get rid of this. Now, when I say treat all other variables as constants, I'm going to treat 4x as a number. Normally, to get rid of this 4, I'd have to multiply by 1/4. But I'm not solving for x. I want to get rid of this entire term. So I'm going to treat 4x as a constant. And I'm just going to subtract 4x from both sides of my equation. What that allows me to do is say 4x minus 4x is 0, and 0 plus 9y is just 9y. On the right side, I have 30 minus 4x. Or I'm going to write it as the opposite of 4x, negative 4x, plus 30. Notice that this sign sticks with the 4x, and we have a positive 30, so I'm going to put plus 30. Now, to get rid of this 9, I'm going to multiply both sides of my equation by 1/9. Notice that when I multiply the right side by 1/9, I put negative 4x plus 30 in parentheses. The reason I do that is so when I multiply by 1/9, I need to multiply this entire side by 1/9, not just the first term on the right side or the last term on the right side. I need to multiply both sides by 1/9. So on the left side, a 9 in the numerator, a 9 in the denominator cancel. I'm left with just y. And on the right side, in order to multiply this entire side by 1/9, I need to distribute. So I have 1/9 times negative 4x, which turns into negative 4/9 x, plus 30 over 9. Now, negative 4/9 x, I can't simplify. But 30 over 9, 30 is divisible by 3, and 9 is divisible by 3. 30 divided by 3 is 10. 9 divided by 3 is 3. So I'm left with y equals negative 4/9 x plus 10/3. When I solved for x in a linear equation in standard form, my answer ends up in slope-intercept form. Now, slope-intercept form is handy when I need to graph a linear equation. And the reason it's handy to graph is I know exactly what my slope is. My slope is negative 4/9. Notice I left it as a fraction. And my y-intercept is 10/3, which is 3 1/3, or 3.3 repeating. So I can graph this line easily. In problem number 2, in order to solve for y, I need to undo what's happening to y. And I'm going to treat all other variables as constants. So to get rid of this 3x, I'm just going to subtract 3x. So I'm left with xy equals, again I'm going to put the x term first, negative 3x plus 25. Now again, if I'm treating x as a constant, this is just x times y. To get rid of this x, I'm going to multiply by the reciprocal, 1 over x. Notice that my right side gets put in parentheses, because I need to distribute this 1 over x to both terms. So what happens on the left side is x and x cancel. I'm left with just y equals. And on the right side, I need to distribute. So I have negative 3x over x plus 25 over x. And I can simplify. This x and this x will cancel. So I'm left with negative 3 over 1, which is just negative 3 plus 25 over x. In example 3, in order to solve for y, I need to get rid of this plus 1, get rid of this plus z, and get rid of this z times. Now I could distribute, but that would just make my problem more complicated. Instead, I just want to solve for y by undoing the order of operations. So before I can subtract this 1, I need to get rid of the things around the grouping symbol. I want to take care of this minus 1 last. So step 1, I want to get rid of this z. Treating it like a constant, I can just subtract it. So I have x minus z, I put my variables in alphabetical order, equals z times y plus 1. Now to get rid of this z, I have z times. So I'm going to multiply by the reciprocal of z. And when I multiply the left side, I need to put the entire left side in parentheses. And the reason I do that is so I can distribute. So I have x over z minus z over z equals, well, 1 over z times z just turns into 1. 1 times y plus 1 is just y plus 1. Well, now I can simplify here. Z over z is 1. Since my grouping symbols are gone after I got rid of this z, I can now subtract 1 to get rid of this plus 1. So I'm left with x over z minus 2 equals y. But if I'm solving for y, I better make sure that my y is on the left side. It's a little extra step, but if I'm solving for that variable has to be on the left. So my answer is y equals x over z minus 2. Last example. I need to solve the formula for the indicated variable. The formula I'm working with is the perimeter of a rectangle. The perimeter of a rectangle is found by taking 2 lengths and 2 widths and adding those numbers together. Now if I want to solve this formula for the width, I need to undo the things that are happening to w. So I'm going to subtract 2l from both sides. P minus 2l equals 2l minus 2l gives me 0. 0 plus 2w is 2w. Now to get rid of this 2, I'm going to multiply by 1 over 2. I need to put the left side in parentheses because I need to multiply this entire half, or this entire side, by 1/2. So I end up with p over 2 minus 2l over 2 equals, well, 1/2 and 2 turn into 1. They're reciprocals of each other. 1 times w is w. I can simplify a little bit. P over 2 minus 2 over 2 cancels. I'm left with just L equals W. Now, I'm solving for Y, so I want my final answer to have, I'm solving for W. I want W to be on the left side. So W equals P divided by 2 minus L.